Welcome back. Another wonderful day of Fusion 360, and we're going to be looking at a few things today, kind of mixing and mashing different skills and workflows together, especially with joints and the construction planes, because they are very, very handy. And if you're not using constructions already, then I really suggest you try to get the hang of how to use them, because they're going to save you a lot of time, and especially a lot of measuring in the future when you want to find a spot between things, over the edges of certain objects, and just draw on something that is not normally drawn on. Well, constructions are your best friend for that. Now, what you see in front of us, in front of you, is a basic little bearing. It's quite a large bearing, actually. I think it's about 100 millimeters in diameter. No, 50 millimeters. Still pretty large for most bearings people use these days, I guess. So whether this is a truck bearing, I'm not sure. But either way, it has a few things inside it. And I used my favorite construction tool, as well as a joint tool that has a bit of a finicky process to get going the way you want for this type of object. It's great for very, very simple stuff. This is the rotating joint. But it's very difficult when you have an object like this, where the rotation center is on an actual thing. It's just a hole. And we'll be looking at how to fix that around, because it will apply to other joints. And I'll kind of talk about the other joints quickly. But in the meantime, I'm going to start at the very, very basics, and we're going to work together. So what I want you to do is create this bearing with me, and we're going to create it right beside it. You can go right in the middle if you want, doesn't really matter. But first, when you select your construction plane, we're going to create a brand new sketch, and we're going to select the bottom plane or the top plane, depending. Doesn't really matter, it's the same thing. And you notice right away that my screen does not snap to the view just like this, where it goes flat on. This is my personal preference. It's in your preferences right there. I think it's under the first or second little tab. It's snap sketch to view. I'll go there right now and just look at it just to show you, because it's nice to know. This is my under design. It's auto look at sketch. Mine's unchecked, so this is just for me. So don't worry if it isn't the same thing for you. I mentioned this in the previous videos. So here we go. Let's make a circle, and this is going to be the outer shell. Let's go 50 millimeters and just hit enter, and that's it. Next, we're going to make a second circle on the inside, and we're going to go 40 millimeters. And this way we have an even 10 distance between them, and this will be the outer shell. What I'm doing is I drew a big circle, and then I drew an inner circle that I'm only going to use a part of it. So we can finish the sketch. We can hit E for extrude, or even Q for press pull. It does the exact same thing in this instance. And let's click on the sort of outer edge of this circle, not the inside part. If you have this clicked, just click in, it goes away. Hit 10 for millimeters, and we will go up. I don't know why it's not working. E, 10. The object you're creating is not visible. That's why. Bodies. Okay. That's why. So there we go. We have our object created. Next, we are going to have to cut out the inside, which is the same cutout for all these ball bearings. So before we even create a ball bearing, we are going to cut out the inside by finding the inside. Now, I know we are 10 millimeters tall, so I can create a cut in the middle and bring it down 5 millimeters. But let's do something easier. Under construction planes, you're going to go down to mid plane right here. Mine is tagged at the top because I use it all the time. The mid plane is something that's super handy for really any object, especially when you want to mirror it later on. And we'll be doing that as well. So hit the mid plane. All you do is select 1, 2 edges, and what it does is it creates a brand new sketch plane that is adjustable. You can move it around if you really want to, but it's right between the two faces or that you selected. There's other versions, mid plane through 2 edges. So if you select 2 edges, the same idea. It does pretty much the exact same thing. It's just a different selection process. And there's way, way more in here. You can go through and probably figure out what they do exactly pretty quickly, or just mess around with them. But there's a few you use often, and one of them I promise you will be the mid plane. It is the best one, for me at least. Okay, so we have that. Now, a little bit of thinking here. So we want to create what's called a torus, and a torus is just basically a ring. You could create a cylinder, but the edges won't be rounded. And the reason why I want to create a torus is because the balls are rounded. So I need that rounded inside, which this is going to save me a few extra steps. We're going to click the plane here. If it doesn't show up, the construction plane is just not on. That's it, the little eyeball. Click that. Find the center of your object, which it should show you, especially if you're on the origin over here. But click the center and pull out. Now, the outside is 50 millimeters, and the inside is 40 millimeters from my memory. And the thing with the toruses is that you want to go from you're building from the center of the torus ring. Let me show you. If I go 40, and it goes pretty large, what you're doing is, if I remove this object here, basically the mark you're putting, which is 40 for us, is the center of the ring, right in the middle of it. That's where you're measuring from. So it's not measuring from the inside edge or the outside edge, it's the center edge. So if you have to kind of divide in half from your torus size in your head, that's fine. Whatever you need to do, that's what you need to do for toruses. We're going to make our torus diameter 7, because if it's 10, it's going to come right to the very edge and going to be impossibly thin in real life. Wouldn't work. So we're going to go 7 millimeters, which gives us a nice buffer on our bearing. And I want to cut. You can create a new body if you want to keep it, but we don't need to keep it. So we're going to cut, and it will give us a nice and very, very clean inner ring cut. Next, we're going to create our ball bearings. Now, since our torus is 7, actually we should, in real life, we should have made the torus 7.1 or 7.05 millimeters. We're going to make it really realistic, but we're not. So next, we're going to make a sphere, and this is something that is very difficult to make in the sketch environment, the toruses and the spheres. It's much quicker to just do it in the 3D environment. So if you're saying, why aren't we doing it with create a sketch? That's why. There's some things that are just better in the 3D environment, and this is one of them. Sphere, I'm going to go back to my construction plane, turn it on. That's another cool quirk of Fusion 360. Once you use a construction plane, it typically gets canceled out. It doesn't disappear. It doesn't get removed. It just gets turned off. You can just turn it back on the side. You can name it if you want to. So select your mid plane again that you made a minute ago. Go back to the center. Create a ball. 7 right there. This is for me. Maybe it's not for you. Just make sure you push 7. New body. Perfect. Done. Okay. Here we go. So now we get to line it up with the outside. If I move it over, let's move it up actually on the Y plane, I'm guessing. So since this diameter is 50 and the inside's 40, I guess is I have to go half that for the radius of 20. And am I right? I think I am. Now, how do you know? Because here's another really handy little workflow tip. You can't see everything all the time. And you can zoom in for days and spend, 5 minutes trying to align things. No, there's no point in doing that. So what we're going to do is use another special tool that I also use all the time, and I hope you do too. It's called section analysis. And you can pin it to the top. I really suggest you should, because it's super handy. You'll see why. If I click that, I already have one created. Let me remove it. If I click it, what you're doing is you're not cutting something up. You're just passing through the object like it's not there, like the old-fashioned clipping in video games. You just walk through walls. And this is where we really want a sideways edge, but we can look at the top to start. So I'm going to click on the top of my outer bearing, and I'm going to drag it down. What's happening is it shows you these lines, and these lines are it cutting through the object. You can find exactly what you need, and it stays there. It's a permanent thing, but you just turn it off and on so you can come back and check things out. So I can see right now, if I go down, if I dropped it down 5 millimeters from the top, that's half of the height there, because the height's 10. You can see that that bearing is right against the edge, so it's perfect. Exactly where we need it. And really that's it, section analysis. If you want to see the sideways view, we can make a new one just for reference sake. And I'm going to put it on, let me remove that plane, on the origin point. And I can just drag it over until I find my ball bearing. And you can see again from the side, you have a section analysis on the side. So these things are super handy to use. Really great tool. Just lock it on the top beside inspect. Next, we are going to make a constant supply of these ball bearings all the way around. But this time, we are going to first create a component out of this ball bearing. And the reason being is that your joints do not like bodies. They only like components. So let's call this ball 1. And we are going to click it and right click and go create bodies from sketch. So all you do is right click there. You can right click here as well. Sorry, click create bodies from sketch. It's all right there. There we go. Now let's see what happens when we make multiples of these, because I have a hunch it will not be put in the same component. Then the video, I think it was video number 2, we use the pattern tool, and this is another handy tool. So just select whatever you want. Make sure it's on bodies, because you don't want the face, that's just the outer shell. You want the whole body to be moved. You can go components too, but we won't be doing that. Let's just go bodies, because I want to do a different sort of process after this of adding to our component. So we're going to take this ball bearing, we're going to copy it around the edge. So find part of that edge. Doesn't matter, there's no center to click on, so it's just whatever the ring is that follows that same direction. And we don't need 3. Let's see what 25 does. Way too many. How about 20? Way too many. How about 15? That's fine. 15 looks good. You can put whatever number you want. You can actually, if we go 17, it might be even closer. 18 looks a bit snug. So I'm going to go 15, and you can do whatever you need to do. Now, handily enough, it put all of them under the same component. So when I click the ball component, it goes to every single one. If this doesn't happen, which I think this used to be different in Fusion, I might be wrong about that. All you do is under your bodies window over here, all you do is click the one you want, and you open up your component list. So I want to put it under the ball component, your bodies. You just drag it down, and what happens is it adds that body to the component. So if you want to categorize stuff into components without recreating it like we just did, let's say you make a whole bunch and you just drag it down and it goes right into the component and it's locked in and you are set. That's really it. Okay, next step, we are going to make the inside ring. So we are going to create a sketch. Click by accident, sketch. Click the top of your outer shell, and then we're going to go to our center diameter circle, which is right here, first one. C is the shortcut. Find the center. The center is usually a little ring. If you can't find it, if you get an X, just kind of drag away and come back. You want the ring. The ring tells you it's the center of whatever plane or object you clicked on. If I clicked on a different object, it would find the center of that. So make sure you click on the correct object. Luckily, right now, we only have one to choose from. We'll click that. We don't want to go 40. Let's go 39. Make it a nice, tight-fitting bearing. I mean, it should be tighter technically, but this is good for now. 39. And then we need a center ring. So how about 20? 20 millimeters center hole. Good. We have 39 and 20. Hit Q or E. Click that outer shell of that and drag. You can click the bottom here. You can go -10, or if I go 0, you can just click the bottom of the object you want to align it to, and it goes right to the exact same distance. I don't want cut. I want new component. but we're going to rename it properly. And the reason why I do this is my workflow, I typically make the body first. I find it, I name the body inner shell 2 because I already created an inner shell over here. And the reason why I do this is because when I make a component, the component takes that name and copies the name onto itself. And if you look, the body is called inner shell 2 and the component's called inner shell 2. If I just created a component from the start without creating the body first, it would be both called bot or component whatever and body whatever number 26. And I'd have to go back and rename both individually, which is something I don't like doing. So I just do that one extra step, which saves me 1 or 2 other steps, I guess. Maybe it saves me 1 step. It's just a personal thing. Here we go. We have our inner shell. We have our, let's call outer shell 2. Right click, create body, or create component, and we are locked. Okay, now we're going to use the joints. Now it's not as pretty as my other bearing. You can make it as pretty as you want. I think just for future reference, I extruded this out, the outer shell, another 1 millimeter on both sides, as well as the inner. I had this, I made these little notches, because some bearings have these notches to lock onto. And it also shows you when it's turning. It's really nicely, you can see the notch moving. And I made an inner ring here on both sides, using the center construction plane right here. I just used the mirror command. So I created a ring, and then new body, I mirrored it with the mirror tool, use this as the reference, and a copy down here, and then I just join them together. And I'll show you that in a minute, but I won't do it all because it's just extra stuff we don't need. So let's do some joint work. First, I don't need the inner shell. I only want the bodies. Now, luckily with the joints, it copies the same joint. It sort of locks the same joint together when you're working with a single component. So it doesn't matter what ball I choose. I'm going to choose the first one, which I think is this one. When I apply a joint to this ball, it applies it to them all in sequence, and they're all locked together in the same disc shape that I have here. Whatever shape they're in, whatever direction they're in, they'll be locked together within that joint. So here we go. Create a joint. Yeah, capture position. And I'm going to select my first object, which is the ball. This stuff don't worry about, just make sure it's on simple. In the second object, I'm going to select the little ring edge here. And this is where we have to do some adjustments, because if you look, it won't do that for you, it'll do this, it'll shake. Now that, under motion, is your joint type. So the rigid joint is basically locked in place. If I move the outer shell, these will move with it from wherever they're locked in. Right now they're locked in here, I can move them over there and they'll be locked in, but they won't actually move. Now the other ones too, sliders, which is on a single plane, back and forth. And then we have cylinders and pin slot, which we could go into details, but there's other videos online right now for those. You can just look online. Planar, which is just, it stays on the same plane surface and it moves in any direction. And then we have the last one, which is a ball joint, or ball joint. So basically something that rotates around a ball like this, but you can give it full movement. And you can adjust different things like limits, which we will do as well. But we want a revolute joint. And this is revolving around a center axis. Now, here's the thing. Since I selected this first ball bearing, and I selected the inner ring here, Fusion kind of assumed that I wanted the middle of this entire ring, which is fine. But we're going to keep it like this for now because we don't need to change it. The next step is to go back to position, and we're going to adjust the offsets. So since the center is half the diameter and the diameter is 20, all I have to do is go minus 20 to put it back where it should have been. If, I think with the other one, I made a mistake and I selected the wrong ball. So it was slightly off a bit. So if it's not lining up straight, let's say when you push minus 20, it's over here and it's angled like this or something, really off. You can see it not align correctly. You selected the wrong ball. And you can go back in your history down below and see which one it is. That was your first before you did the, where is it, right here, the pattern. Just make sure you're the right one. Otherwise, you're going to get that sort of issue. Let me go back here. Yes, capture, motion, perfect, select, and select. Okay, so I'm going to -20. I'm going to explain this as quickly as I can. And I want to minus, I think it was it 10? No, it's going to be, it's not 5, is it? Oh, interesting. Because it was up here, I assumed it'd be all the way down for some reason. It's one of those little slips you get sometimes when you're thinking and moving all at once. There we go. We are now locked in, and we can move it later in this as well. And if I check my analysis, I can actually see they are all exactly where they should be. So watch this. And here's your first problem. And this is something people always forget with joints. I'm going to grab this because I can grab these and I can rotate around. I can just drag. Watch what happens here. The whole thing moves. And here's our next thing. Fusion wants something to be the reference. Fusion loves references and lists of references. I've mentioned this a ton of times. Keep the references as simple as you can, and especially keep them aligned in your head as you create things, because you can really get messed up. Our reference for this ball bearing is going to be the outer shell. That is going to be locked in space. So what you do is you select your component here for the outer shell, right click, and you do what's called a grounding. And all it does is basically it sticks this to the whatever ground we have in Fusion, and it won't move anymore. Because if I don't have this, I can drag it. But then if I ground it, I can't move it anymore. I click, nothing happens. That's what grounding does. Make sure you capture the position so it stays. Now I can actually rotate these all the way around. That's it. As simple as can be. We have our offsets done. We have our grounding done, which you will need for a lot of joints. You need that reference point for Fusion. And we have our joints now moving in the right direction. The other thing I mentioned was adjusting things. So I don't need these joints, but this one is the one we just created. And we're going to work with the joint limits. And this won't be for this exact bearing, but let's say something else. Let's say you only want it to rotate a certain amount, like as an example, a clock hand. You only want it to go halfway around. You click the minimum, maximum. They both highlight anyways. And your minimum usually stays around 0 degrees. Your maximum, we want to go 180. And what happens is you get this limit where it can only move in this space. It won't move over in this space. So if I rotate this now, it should stop. Yeah, it stops. It won't move anymore. My mouse is moving, but it's not moving all the way around. So it locks. That's what a joint limit does. And you will have joint limits for many, many joints. It also depends on the object you are creating. But that's the basics of that. Again, there's so many videos online that I don't need to go through it in detail. The next step is to take our inner circle and do the exact same thing. Create a joint. Select our inner circle. And then select our ring to rotate. Hit OK. This one we don't have to offset because it is technically in the exact same center ring as the outside circle. So now I can rotate it. You can kind of see it's rotating. If I add a texture to it, you can see now it rotates even more. The same thing. But look at this. The inside balls and this part are usually rotating together. They're not in lockstep, but they do rotate at the same time. Just the balls are rolling, so it's slightly a bit, it's off. some physics for you if you want to really get into that kind of stuff. So here's the next step. We're going to lock these two together. This is a sort of a second tier joint, and this is something that people don't usually think about, and it can really mess up your objects if you go way too far with this. Because one thing is, it's a warning, Fusion does not like multiple joints on the same object doing the same thing. So again, just keep track of it. It's the reference problem. Keep track of it in your head as best you can, because there's no real list of how many are on what. And when you select all the joints to look at them, it doesn't really show you much, but a little dialogue in the middle of whatever kind of joint it is. So this is where people get messed up and they really lock their projects. We are going to take the outer shell, get rid of it for now, just eyeball it out. Oh, we didn't cut the inner shell. I'm sorry. Let's do that. Torus, I need my plane. Select the center. I'm going to come out 40. We need it to be 7. This is going to be pretty quick. Don't cut it. I want new body. The reason why I don't want to cut it is because it will cut the balls as well. So here's our combine tool. Select our inner shell and our new little torus. Cut. And now the bearings are still there, but it only cut what I told it to cut. And now it's done. Next step is to lock it all together. So here is our standard joint. There's two ways of doing this. This is the long way first. Select your object, make sure it's on rigid, select your secondary object, and it locks together, but you want to -20 and then 5. You see so many steps here, and now it's locked. So now if I rotate, they rotate together with the outer shell, and if I look right here, you can see the edges, they're all rotating together. That's the long way of doing it. If I take that rigid and delete it, here's the best way to do it. Trust me. Select your inner shell or select your ball bearing, doesn't matter. Hit Shift and J on your keyboard. That doesn't matter. But as built joint is sort of a quick rigid joint. You can select other ones, but this is the quickest way to create a joint, and I typically use it for most joints, but mostly the rigid joint altogether. So again, it's first object you want to start with, Shift J, hold Shift, push J for jack on your keyboard, and select your next object, and now that's it. They're locked. Really simple. Let me go back and show you again. Back, 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 back. There we go. They're not locked. Click, Shift J, click, done, locked. Much faster. There's no more offsets to change around. And the difference, the real big difference between these is you get to keep the offset that you already have between every object, because this is offset from here, this is offset from here, this is offset from here. It's all different offsets. So instead of having to redo those kind of things like you saw a minute ago, that's the quick way of doing it. So this is the basics of sort of a next step in learning to use some key tools in Fusion, where we have the construction planes, which are super handy for creating new objects. We have our joints. We use the combine tool, which is super common. If you don't have it here, I really suggest you take it and you pin it to your top. And then we also used, we didn't use the mirror. Let me use the mirror. And this is with the plane as well. So I'm going to create an inner ring, which most bearings have. So select this plane, select here. That's 20. Let's go 25. That's good. Hit Q. You can hit E as well. Doesn't matter. 1 millimeter. New body. Now I didn't join it together for this reason. New body. Select here. Here's what I'm going to do. My plane. Mirror. The object I want to copy is already selected. The plane I'm going to mirror it on is our center plane. Done. Hide. Combine. Click. 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 Move to join. Done. Really fast. You can see how quickly you can make objects if you know these steps. You get the hang of it. That's really it. The next thing that kind of my pet peeve is hide those joints, because I really don't like seeing those joint limits. If I want to see them, I'll bring them up. Otherwise, I always hide them myself. Maybe you don't. Up to you. Analysis. Let's check it again. Yeah, looks good. This is not a full bearing. This is missing some pieces and parts and little standard things on it, but this is the basics of it. Now we have a bearing that works, and the initial one doesn't, because if you look, the inside balls don't move. This one does. There you go. Thanks very much for watching. Hope this helped, and I will see you next time.